Hey everyone, I'm Ms. Milkowski, the mathematician, and today we are going to solve proportions. All right, so we have a proportion here, and when I say solve the proportion, that means find the value of x that would make this true, okay? So, you probably remember from solving proportions that were easier than this, one of the simplest ways to do it is to set the cross products equal to each other. So that's what we're gonna do. So here's something where actually I'm going to use a different color so you can see. The cross products, okay, are the quantity x plus 9 times quantity x plus 2, and then x times 2. Now here's the issue that I often see with students. So they mean well. They're like, oh, it's x plus 9 times x plus 2. So they go x plus 9 and then they'll go times x plus 2, all right, equals, and then they'll do x times 2, or a lot of times they'll write it as 2 times x. Now, here's the thing, okay? If you don't put parentheses around that first binomial, okay, or sometimes they'll put parentheses around the first binomial but not the second. I've seen it both ways. If you don't put parentheses around each binomial, you're going to make a mistake. Because look at this. If there were no parentheses around this first one, okay, let's say I took them away, what you would do is when you come back to look at this, you're going to say, oh, it's just 9 times x and 9 times 2, but you forget that it's also x times x and x times 2, all right? So that is just so super duper important to put parentheses around each numerator and each denominator, if you will, okay, when you make the cross products. Ooh. Okay, so here we go, we're gonna put them in. And I've even gone so far as to tell students, put parentheses around everything. You can take them away later, you know what I mean? But I'd rather have you put parentheses around everything and then be like, oh, I didn't need that, than not, and then distribute something incorrectly or forget to multiply something by something else, all right? Perfect, so please, please, please don't forget to put parentheses around your binomials and in fact around everything, all right? So let's multiply the quantity x plus 9 and the quantity x plus 2. So we do x times x, which is x squared. And I always draw your distribution lines, okay? It prevents mistakes. X times 2 is 2x. And then 9 times x is plus 9x, because this is all positive. And then 9 times 2 is 18. And then that equals 2 times x, which is just 2x. Okay, so there's two ways we can do this. We can combine like terms, or because I see a 2x on both sides, I can just subtract 2x from both sides. I personally I hate like doing extra work, so because I recognize a 2x on both sides, I'm just gonna subtract 2x from both sides. And now what I'm looking at is x squared plus 9x plus 18 equals 0. Now, just as a side note, for those of you that are like, what did you just do? I'm gonna come over here quickly and show you. So it was x squared plus 2x plus 9x plus 18 equals 2x. So I'm just going to show you the other method that you could have done here. You could have combined like terms. You have a 2x and a 9x. Okay, so that's going to be 11x. And then plus 18 equals 2x. Oops, sorry. And then you want to get everything on one side. Okay, so subtract 2x from both sides. And you end up with x squared plus 9x plus 18 equals 0, which is exactly what we have here, except I kind of saved the extra work. Just think about it this way. The more steps you take, the greater a chance that you're going to make a mistake. So I always try to take the fewest steps possible, and maybe it's because my brain is constantly searching for patterns, and when I notice something, I just handle it. So again, however, if you're like, no, I like to get everything together and then I want to subtract, you know what? I think that's fantastic because that's working for you and you're probably going to get the problem right if you do it that way than if you try to do it this way. So I want to stress that either way is fine. Me personally, I do it this way, but if you do it that way, that is just as awesome. Okay, so I'm going to erase this just so we have more room. All right. Perfect. Okay. So now what I recognize right here is I have a quadratic and I can factor, right? Well, hopefully. So let me see what I can do here. Looking for what two binomials multiply to this. So I need two numbers that multiply to 18 and add to 9. and that's going to be 6 and 3. Perfect. Okay, now again, if you kind of missed how did I get from here to here, I needed two numbers. This is the product, okay, and then this is the sum. So they have to multiply to 18 and they have to add to 9. Because this is positive, they both have the same sign, and because this is positive, that sign is a plus. If you want to see kind of a way that you can write it out, and I'm not going to say in step form, but maybe a little more organized fashions, because, for example, you may not recognize this, or what if you had like a number that had tons of factors, like 48, you know what I mean, or 72, or something like that. What you can do is if you write it up here and you say, okay, I need it to multiply to this. So the first thing is we know everything's positive, which makes our life easier. We don't have to worry about signs. So start going through the factors of 18. So 1 and 18. Well, what do 1 and 18 add to? 19. That fails. I want it to add to 9. Next, I just count up. So 1 goes into 18. Well, obviously 1 times 18. 2 goes into 18. That's 2 and 9. If I add them, I get 11. Fail. Again, I want 9. So 3 also goes in. 3 goes in, and then that's 6. 3 times 6 is 18. If I add them, I get ding, 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 boom. So that's how I know that 3 and 6 go here, okay? This, I stress, is very important, and do it. I mean, don't try to be a hero and don't be like, I'm going to do it all in my head and I can figure it out. If you can, awesome. If you can't and you want to write it down in an organized fashion, do that. Both ways are great. Okay, awesome. So now what we're going to do is, all right, so now what we're going to do is we can use the zero product property here. So I'm getting kind of low, so I'm going to rewrite this up at the top here. So I have x plus 6 times x plus 3 equals 0. So remember, the zero product property states that if these two multiply together is 0, then either this is 0 or that is 0. So either x plus 6 equals 0, and then subtract 6 from both sides, and you get x equals negative 6. Or x plus 3 is 0. Subtract 3 from both sides, and x equals negative 3. Awesome. So those are our solutions. X could equal negative 3, or x could equal negative 6. Both values would make this true. So now you might think, okay, we're done, but what do you always have to do? You always have to check your work, right? 100% of the time, check your work. And I know you think it's annoying. I don't have time to do this. I have to finish the rest of the test. Well, you really need to, because what if you made a mistake? You know what I mean? What if you made a mistake? The whole problem's wrong now. So you can do it pretty quickly. So let me show. I'll even do it in blue, okay, over here. So all we do is we say, do these work. So, okay, when x equals 6, okay, or sorry, not 6, negative 6. When x equals negative 6, is this a true statement? So I plug in negative 6 wherever I see x. So negative 6 plus 9 over negative 6. And does that equal 2 over x, which is negative 6, plus 2, okay? Some of you right away might do this in your head and say that's a true statement. We're going to take it step by step. So negative 6 plus 9 is positive 3 over negative 6. And we want to know, does that equal 2 over negative 6 plus 2, which is what, negative 4? Awesome. Again, you might recognize right away that it's true, and it is. But just if we simplify them even more, we get negative 1/2 equals negative 1/2. Perfect. So this works. Awesome. Now we're going to check x equals negative 3. So we're going to do the same thing. We plug in negative 3 wherever we see an x. So that's negative 3 plus 9 over, I'm going to cover this marker up because it is I'm living dangerously. Keeping that open. I'd get it on my shirt or something. Okay. Over x, again, which is negative 3, and that equals 2 over negative 3 plus 2. So negative 3 plus 2. Okay, so we want to know, is that a true statement? So negative 3 plus 9, that's going to be positive 6 over negative 3. And does that equal 2 over negative 3 plus positive 2 is negative 1? Yes, you can recognize that right away, but let's take it to the final step. 6 divided by negative 3 is negative 2, and 2 divided by negative 1 is negative 2. Ding, ding, ding. All right, so both work. So this is great. So our answer is x equals negative 6 or x equals negative 3. Perfect. I think you did a great job. And the only thing I want to remind you when you're doing this is make sure that you put parentheses around what you're multiplying, okay? It's not a baby thing to do. Some kids are like, oh, I don't need to do that. I'm like advanced. And I get it. You're advanced, you're awesome, and you're really good at math, every single one of you. But you're not immune to mistakes. Everybody can make them. I make mistakes. One time I was working with a kid and I distributed incorrectly 3 times. And I didn't do it on purpose to prove a point. I genuinely was just going too fast. So you have to understand mistakes happen. So what's even more important than teaching you math is teaching you strategies to prevent those mistakes. And this is one of those strategies. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.